So lesson 1, the fundamental counting principle. There should be thunderous echoing and rolling because it's fundamental. We want to investigate counting without actually counting. And we want to do it without people talking. Shh. Thank you. Example 1. A cafe has a lunch special consisting of an egg or a ham sandwich, E or H, milk, juice, or coffee, M, J, or C, and yogurt or pie for dessert, Y or P. If you choose one item from each category, how many different meals can you form? One way to do this would be to use what's called a tree. Would be to say, okay, my first choice is egg or a ham sandwich. And then from there, I have 1, 2, 3 choices. 1, 2, 3 choices. It can be milk, juice, or coffee. Milk, juice, or coffee. Do you see why this is called a tree? It sort of looks like branches. It's called a tree diagram. And then I have 2 choices, 2 choices, 2 choices, 2 choices, 2 choices, 2 choices. Yogurt, pie, yogurt, pie, yogurt, pie, yogurt, pie, yogurt, pie, yogurt, pie. This is the first brute force approach, and we're going to find shortcuts for this. But how many outcomes are there? Count the number of branches along the bottom. Count. This is the fundamental counting principle, so we're going to count. How many? Can anyone see a way that maybe I could get that 12 without drawing this tree? I mean, this tree was kind of nice, but like what if the answer had been 40? That'd be a pretty branchy tree. I don't think you could fit that on a piece of paper very well. First of all, 12. There's the answer. How many different levels, how many different categories were there? Draw 3 blanks. Foster says, my mom says I'm good at drawing a blank. No, we mean in math. How many choices were there for the first category? How many choices were there for the second category? And the third? Can you see a 12 hidden anywhere in there? Connor, what? The fundamental counting principle says when you're making choices, you multiply. And we'll write that formally a bit later, but that's basically the fundamental counting principle. And in fact, Christina, one of my fallbacks, if you give me a nasty question, I draw a blank. I mean, literally, not figuratively. I start drawing blanks for each choice, and I'll fall back and I'll say, well, how many choices do I have for this first category? How many choices do I have for the second category? It gets more complicated, and so I won't be able to use that strategy all the time, but we start out here, ice cream. The cafe also features ice cream with 24 flavors. You can order regular, sugar, or waffle cones. Suppose you order a double cone with 2 scoops of ice cream. Okay. How many choices of cone do we have? Read the question. How many choices of cone are there? How many choices of flavors do I have for the first scoop? What about for the second scoop? It depends. Rachel, it depends on whether I'm allowed to have the same flavor twice or whether I am only allowed to have that flavor once and then I got to pick a different flavor. This question is not clear. The phrase we say is, are you allowed repetition or not? Is it without repetition? Then there's 23 choices. Is it with repetition? There's 24 choices. The question will usually tell you, or it will be obvious from your life experience. So you've purchased ice cream before. Is there any rule that says that you can't get 2 scoops of the same flavor? You are allowed to repeat, so how many choices do we have? 24. How many different double cones are possible? Cone, scoop 1, scoop 2, 3 blanks, 3 times 24 times 24. And we're already approaching the level of we wouldn't want to bother counting and listing all of these. What is the answer? 1728? I mean, it's theoretically possible. You could try listing 1,728 possible outcomes. I guarantee human error, you'd miss a couple. And then you'd have to go start over. So already a very, Christine, simple question in my mind, nothing complicated, but the answer, the numbers get big. But what's the fundamental counting principle? It says when you're making choices, if you know how many choices at each stage, you multiply. Turn the page. So a computer store sells 5 different computers, 3 different monitors, 5 different printers, 2 different multimedia packages. Try this one on your own. How many different computer systems are available? Try it on your own. I'll freeze the screen. Is that right? When I said try this on your own, I really meant for you to try this on your own. Right? Oh, and by the way, you can use calculators, but start learning that when multiplying, you can group your multiplication to make it easier. I went 10 times 15, which I'm going to argue even Jordan can do in his head, right? If you're lazy and you want to start doing stuff in your head, clue in, group the multiplication into easier stuff. So what's the fundamental counting principle? It says this. If one item can be selected in m different ways, and another item can be selected in n different ways, what's the total number of ways it can be selected? What did you say we do with the numbers? Oh, if I don't put a sign between letters, that means times, yes? Oh, and if you got another choice, multiplying with that. If you got another choice, multiplying with that. So let's start to some examples. How many different 2-digit numbers are there? What I want to do during this unit is give you some good tools, some good strategies, and the first one I've already given you, it's drawing a blank. I put the blanks here, but if they did not, I would go blank, blank. The second strategy I want to give you is an analogy. I want you to imagine a little cloth bag, like a Scrabble bag with Scrabble tiles inside of it. And in fact, until we get good, we're often going to draw it because it takes all of 1 second. So here is my little Scrabble bag right there. It says, how many different 2-digit numbers are there? How many different digits are there in the first place? What would be in this Scrabble bag? I think a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, and a 9. And I kind of jumbled them on purpose because I didn't want to accidentally think they were in some kind of an order. This is going to be my analogy, my metaphor. And when in doubt, often I'm going to quickly sketch a little Scrabble bag with the possible outcomes. And I'm going to use my imagination. Shake it up. Reach in. How many choices do you have for the first digit?
10.
9 or 10? Which one? Why is 10 wrong? Oh. What? Someone said it. I think I heard someone say it. We're not allowed to start with a 0. We don't start digits with a 0. So for the first digit, we're going to decide that from now on because I guarantee a great question on a test is to give you little number questions like this. We're going to say we're not allowed to start with a 0. So how many choices for the first digit? Not 10? 9. Or is that Finn saying no? Oh, he's not here anymore. 9. A German student saying no? No? The Scrabble tile goes back in. We shake it up again. How many choices do we have for the second digit? Any restrictions at all on the second digit? No? So how many? 10. In your head, how many different two-digit numbers are there? 90. Okay, let's make it a bit more restrictive. Example 3 says, in each case, how many different two-digit numbers can be formed using the... Okay, now they're not saying use all the digits. I'm going to draw my Scrabble bag, and it looks like I have a 0, a 1, a 3, a 5, a 7, and a 9. And we have two cases. In the first one, repetitions are allowed. What that means is after you pull a number out of the bag and look at it, it goes back in. Shake it up again. B says repetitions not allowed. What that means is once you've pulled it out of the bag, put it aside, shake up the new bag with the new different numbers in there, and you're picking from this new group. Okay? There's my analogy. So if repetitions are allowed, how many choices from this bag do I have for the first digit? Careful. Why not 6? Okay, we're not allowed to start with a 0. So I got 1, 2, 3, 4, 5 choices. Maybe you picked 7. But repetitions are allowed, so the 7 goes back in, shake it up again. How many choices do I have now? How many two-digit numbers can be formed using those digits if I'm allowed to use the same number more than once? 30. What if repetitions are not allowed? What kind of numbers are we forming? How many digit numbers? This is the first time I haven't drawn the blanks for you. First thing you should do is you should draw 2 blanks. It's a great, your question's no longer blank, no pun intended. You feel better. I'm good at drawing a blank, whatever joke you want to make, but hey, this is going to be my strategy. All right. How many choices do I have for that first digit? Shaking it all up, we're starting over. Okay, 5 again, because I can't start with a. Okay, so I'm going to put a 5 here, but now I'm going to imagine that I actually did pick something. What did I pick? Not a 0. What did I pick? A 7. Cross it out because you're not allowed to put it back in the bag. Right? Repetitions are not allowed. How many choices do I have for the second digit? By doing that one little step, I hope it's obvious. How many? Roy? 5. Answer? Oh, part C. I didn't include it, but we're going to add it. How many numbers repeat? Can you see from part A and part B how many numbers repeat? How many numbers could we form grand total in part A? 30. How many numbers could we form if we weren't allowed to repeat? Part B. 25. So how many must repeat? Tiff,
5.
did you hear? 5 of them must be the repeating ones. Otherwise, I would have got the same answer for A and B. So this trick number, whatever we're on, 3. Sometimes to find an answer, it's easier to find the opposite of the answer and subtract. In other words, if I had said to you, how many don't repeat? I wouldn't try that. I would find out how many grand total? 30. How many repeat? 25. And then I would say, oh, whatever's left must have been the ones that do repeat. Sorry, how many don't repeat? 25. Whatever's left must be the ones that repeat. We call that the complement. We'll learn that trick later on, but I'm showing it to you now. Fundamental counting principle says multiply, multiply, multiply. Stuff you've always wondered. A true-false test has 7 questions. Suppose students answer each question by flipping a coin, by guessing randomly. Okay. How many possible answers are there for each question on a true-false test? How many questions are there grand total on this test? 7? Draw 7 blanks. How many choices do you have for the first question, Sean? For the second question? For the third question? For the fourth question? For the fifth question? Sixth question? Seventh question? You could go 2 times 2 times 2 times. Is there a shortcut for multiplying 7 2's together? Did you learn a handy-dandy notation with exponents? Are you saying this is really the same as, what's that? Sorry? 128? That's how many different answer keys you could create. That's how many, if you were guessing randomly, how many different ways you could guess. Of all of those, how many are perfect? Ellen, only 1. So what's the probability of getting perfect on a true-false test with 7 questions by randomly guessing? Only 1 out of those 128, which is what as a decimal? Kind of curious. Times 100% to make it a percentage. You don't even have a 1% chance of guessing right. You've got a 0.8% chance of getting perfect. By the way, mine gave me my answer in scientific notation. This is 0.0078125. Do you guys write true-false tests very often? Do you write multiple choice tests occasionally? Example 5. A multiple choice test has 7 questions. How many questions? With how many possible choices for each question? 4. Let's suppose you randomly guess here. You've always wondered this. I'm sure you have at least once. How many choices are there for each question? How many questions are there grand total? Draw 7 blanks. 1, 2, 3, 4, 5, 6, 7. Brandon, how many choices do I have for the first question?
4.
How about for the second question?
4.
How about for the third question? Are you spotting a little pattern here? What's the shortcut? 4 to the?
To the 7.
Which is what? 1, 6, 3, 8, 4. Of all those possible ways of guessing, how many are perfect? Only? You want to get perfect by randomly guessing on only a 7-question multiple choice test? The odds are 1 in 16,384. There's the moral of your story. Study. Yes? Friday is your test. Some of you said you haven't finished the review. You got 15 minutes to work on that. Get any other missing assignments in as well.